Hey everyone, welcome to this video. We are going to talk about long short-term memory. So earlier on in this course, we talked about recurrent neural networks, also known as RNNs, and a quick refresher. Sometimes order matters. I have these two sentences where the words are in a different order, or the words have been rearranged, so to speak. And because the words are in a different order, in the first sentence, I like carrots, whereas in the second sentence, I like cookies. If our model does not take order into account, performance will suffer. So we can think of the hidden state as memory to take order into account. Okay, a quick pop quiz. I would karaoke often at the local park during my free weekends. I have gotten better at blank. Hopefully you said singing. Karaoke helped us realize to use singing even though it is at the start. In a RNN, long sequences become an issue. Why is that? During backpropagation, the gradients of early layers are calculated by multiplying the gradients of later layers. Long sequences will have many multiplications, so more likelihood of vanishing or exploding gradients. This again essentially means in a RNN, long sequences become an issue. And here's a slide quickly reviewing why vanishing gradients and exploding gradients are not a good thing. And if you're rusty on your knowledge of vanishing gradients and exploding gradients, I have a dedicated video for both these topics from earlier on in the course, so feel free to rewatch that. Okay. Another way I like to think of why long sequences are an issue for RNNs is that, again, think of the hidden state as memory. So gotten better at is at the end of the sequence, or it occurred more recently, so to speak. So our hidden state has really good memory of gotten better at, and so the text font is really large. However, I would karaoke is at the start of the sequence or more distantly at the beginning of the sentence, so our hidden state barely remembers it or has a bad memory of it. So I would karaoke is in really tiny font and barely readable. Hopefully that makes sense. Enter LSTM or long short-term memory. LSTM is a type of RNN which helps with vanishing and exploding gradients. And LSTM includes a new state, the cell state. The cell state can be thought of as long-term memory, whereas the hidden state that we've been reviewing so far can be thought of as short-term memory. So now in addition to the hidden state, we now have cell state for long-term memory. And this cell state says, okay, let's remember the word I, but once we hit the word karaoke, let's remember the word karaoke for the rest of the sequence. And once we get to the end, even though karaoke was early on or way back early in the sequence, it still remembers karaoke. And so now our LSTM makes the correct prediction that the last word should be singing. To close things off, let's talk about LSTM gates. LSTM gates are used to control the cell state. Input gate controls what to add to the cell state. Forget gate controls what to remove from the cell state. And the output gate controls amount of cell state to use for the next hidden state. Please memorize this last part because at the end of the day, predictions are still made with the hidden state. And these gates have weights that are optimized during training. So even though our LSTM diagram is a little bit complex, when it comes down to it, this diagram, which we've gone over so many times during the course, is still what is happening behind the scenes. We ultimately want a model with the best weights, which can be thought of as like the knowledge of the model. We want the best weights or best knowledge to get the best outputs or predictions possible. We use the error/loss to update the weights to be better to hopefully again give really good predictions or outputs, such as a model that can tell the difference between a picture of a dog and a picture of a cat. All right, that's it for this video. Thanks for watching.